So chapter review 1, problem 15. Find the coefficient of the term in x squared in the expansion of this binomial to the 8th. So let's see, guys. Once again, let me reinterpret this binomial as an addition instead of a subtraction. That's what you have to do before you expand the binomial. So this is the first term in the binomial plus the second term, which should be considered as minus 4x to the 4, like this, and your binomial to the 8. And then you can apply the formula for the binomial theorem. Okay, let me tell you what this problem means in Spanish, guys, because probably in English doesn't sound so good, so understandable maybe. So, lo que te están pidiendo aquí es hallar el coeficiente del término que contiene x cuadrada en la expansión de este binomio. Repito, hallar el coeficiente, es decir, el valor numérico que multiplica. Aquí el coeficiente sería 3, ¿cierto? Aquí el coeficiente sería 2, en dos términos completamente random, ¿sí? Pero sería menos 4. 3 y menos 4. Cometí ese error. El coeficiente sería 3 y menos 4. Creo que dije 2. Entonces, lo que hay que hacer es, okay, let me switch to English. In theory, what we should do is expand this binomial, right? In all of it, all the expansion, right? Which will have 9 terms. 1, 2, 3, 4, 5, up until 9 terms. And observe the one that contains x squared. Okay, one of these 9 terms will contain as a variable part, as its variable part, will contain x squared and x squared only. That's what we mean by the term in x squared. You see what I mean? Let me try to give you. Well, let me hide this, and I need you to understand this very well. Okay, for example, take a look at this. We have a binomial, and we have its expansion in here. All of this is expansion. All of this. How many terms do we have in expansion? We have 7. 1, 2, 3, 4, 5, 6, 7. And for example, if you read somewhere the term in a squared, that's what this is the term in a squared. This is the term in a to the 5th. This is the term in a to the 4th. The coefficient in the term of in a to the 4 is 135. So I guess you got the idea by now. Okay. Now the thing is this, guys. Do we need to expand the whole thing? Because it's a lot of terms, right? It's 9 terms. Do we have to do that? No, not necessarily. Just realize that, well, not necessarily, but just as an exercise, let's actually do it. Yeah, I think it's a good exercise. So I'm just gonna write the full expansion. Come back in a moment. Okay, guys, so here's the full expansion. Okay, here's the full expansion. Let me tell you what I did. This is the binomial to the 8 equals this, which is the first term, plus the second term, plus the third, plus, and so on and so on and so on. I ran out of space, so I made a connector from here to here. This is not advisable, obviously. Try to avoid this type of thing. If you ever do this on an exam, guys, you need to be very, very, very clear about what you're doing. Like, explain your reader, like, please go above, I don't know, do something explanatory. So here's the full expansion. Now let's find the term that contains x squared and x squared only as its variable part. The thing is this, guys, do you need to actually simplify every single term of this? Like, do you need to find this coefficient? No, no, you don't. You don't need to find these things, guys, because they're only asking you, in order to find this coefficient, in order to find the term in x squared, I only need to take a look at the variables. I only need to take a look at the variables. Look in here, we have the variable part here is 1 over x squared to the 8, and here is x to the 4 to the 0. By the way, don't make the mistake of calling this x to the square to the 8. That would be incorrect because the variable is in the denominator. So if you only considered the variable in here, it should be written like this: 1 over x to the square to the 8, which is not the same as x to the square to the 8, clearly. Okay, don't make that very dumb mistake. So let's see. For example, take a look at this one. What would be the variable part of this term, of all of this term? Let's find it out. I only take a look at the variable part. What is the variable part of this factor? That would be 1 over x squared to the 8 and times x to the 4 to the 0. You see how I'm not considering neither this coefficient, nor this coefficient, nor this minus 4, because I don't care about them. I only care about finding the variable part. Now, what is the variable part of this? That's going to be, by using loss of exponents, you're going to get 1 over x to the 16, right? Because, well, I'm not going to explain loss of exponents. And x to the 0, and therefore this is 1 over x to the 16. So in the end, the variable part of this term is this, guys. This is the variable part, and it's going to be accompanied by some coefficient at the front in here. I don't know, it could be a 16, 100, whatever you get out of the multiplication of this times 3 to the 8 times minus 4 to the 0. That's going to be the numerical coefficient here that multiplies 1 over x to the 16. But you see, we only cared about this in the rectangle. So let's do it for the next. Look at this one. The variable part in here is 1 over x squared again, but now it's raised to the 7, and in here is x to the 4 to the 1. Once again, let's employ the loss of exponents. We get this times x to the 4, and at the end you have x to the 10. Once again, we don't have yet what we want, which is x to the square. We just keep going like this. You see? We just keep going like this. You don't need to simplify to the utmost every single term. You don't have to do that. Just follow the same scheme that I'm telling you. Now this one, 1 over x squared to the 6, x to the 4 to the 2, loss of exponents, you get this times x to the 8, apply loss of exponents, and you get this. Still not the term in x squared. Now what about this one? I guess by now you already caught the idea, right? It can actually be found visually. You don't have to do what I'm doing here. For example, in here, 1 over x squared to the 5, that's going to be 1 over x to the 10, right? And x to the 4 to the 3, that's going to be x to the 12. And bingo, we have found the term in x squared. Because after you multiply these two factors, this and this, you're going to get x squared. So this is the one, guys. This is the one. If you don't believe me, simplify it as you would usually, normally, and you're gonna get this. You're gonna get that the variable part of this term is gonna be x squared times some coefficient on the front. So this is the one. So we can actually erase all the expansion. I don't care anymore about this, and I'm gonna in blue select this term. This is the good one. We know which number is it? 1, 2, 3, 4. It's the fourth term in the expansion, the fourth term. So let's write it down and let's simplify it. 8 choose 3 times 3 over x to the square to the 5 times minus 4x to the 4 to the 3. And now we can do this, right? So once again, 8 choose 3. Let's go to the TI and find that number. Menu, probability, combinations, 8 choose 3. It's 56. Okay, let's bring that number over here. So this is 56. And then just raise this fraction to the fifth and this other factor to the 3. 3 to the 5. How much is that? Let's find out. 3 to the 5. 243. Over x to the square to the 5, which is x to the 10. Well, I mean, we already know what the variable part will be, right? It's going to be x squared. Minus 4 to the 3, that's going to be minus 64. And x to the 12. And then we get 56 that multiplies 243 that multiplies minus 64 that multiplies x squared. And this is, guys, that coefficient. Okay, suppose you are on paper 1 and you cannot use a calculator. Then leaving this expressed as a multiplication, it's fine. You're not going to be doing this type of multiplications on paper, right? I mean, they're not way too long, but if you don't want to lose time, you can just leave it like this. But anyways, let's actually get that number in the TI 56. It's going to be 56 times 243 times minus 64. So it's this number, minus 870912. Okay, this number right here. So let's write it down, and we're done. That's the coefficient, minus 870912. Is this the answer that the book provides? I think so. We're on problem 15. There you go. It's this one.